Uh, hey, marine science students, for lesson 2.2, there is a video that goes along with it. I'm going to go ahead and walk you through what you should have on your study guide based on that video, but please do not watch this until you have watched the video. So go back and click on the continental drift video and make sure that you're familiar with that. Really, what I'm going to explain to you here by giving you these answers will not be nearly as helpful as it should be unless you have already gone back and watched that video. So please watch that first. Don't just come here and get the answers for the 2.2 study guide. All right, so for number one, it says describe the theory proposed by Alfred Wegener. What is Pangaea? The name of the theory that he proposed was continental drift. That's all we want you to have there. And Pangaea, as most of you probably know, is a massive supercontinent where all of our continents were joined together and have since separated. Number two, how does the apparent fit of the continents support Wegener's theory? Here we're walking through each of the four pieces of evidence. So the first one is the fit of the continents. The example he gave was South America and Africa. They clearly look like puzzle pieces. Hard to consider that a coincidence. So the continents appear to fit in a way that would be hard for it to be coincidental. Number three, what is fossil correlation and how does it support Wegener's theory? Fossil correlation is the fact that fossils line up on different continents across oceans, were places where we would not expect them to line up. The example that he gave was the Mesosaurus. He gave a couple of others as well, but that was his main focus. They can be found completely across the ocean on separate continents. The only two places where that fossil can be found, the only reasonable explanation that really seems to make sense is that those two locations were once joined on this massive supercontinent of Pangaea. Number four, how does rock and mountain correlation support Wegener's theory? Similarly to the fossil record, mountains line up across continents as well. He gave the example of what are Rocky Mountains, but if you were to push those continents together and join North America with Europe, in the place where it appears that it probably did, that mountain range actually continues across Europe. And so not only the shape of the range itself appears to line up, but also what the mountain range is made of happens to be the same as well. Geologically, they are identical, which is possible without this theory, but it certainly adds to the evidence that supports this theory. Number five, how does paleoclimate data support this theory? What are glacial striations and how do they support Wegener's theory? And then how about coal deposits? So for glacial striations, they are scratches on the rocks that come from glaciers moving across those rocks. And those can be found in tropical locations, which are not currently frozen, and so those locations, it would maybe make sense that they were once somewhere else in a colder place where there would have been the possibility of glaciers moving across them. And then for the coal, it's the opposite. Coal is formed by tropical plants that are compressed over a long period of time and form the coal. But this coal can be found in places that are not tropical. It can be found in some very cold places that suggest that those cold places used to be somewhere else where there would have been a tropical environment. That's at least one possible explanation that helps support this theory. And then finally for number six, how did Wegener die? He died of exposure on an expedition in a very cold location, went out to get food and was not heard from after that. And how was his theory received by the scientific community while he was alive? It was not received well. It really was not until several years after his death that the idea of plate tectonics came along and we started to piece together some of the other evidence that would help to explain why. That was Wegener's big weakness. He could do a pretty good job of showing that the continents had once been connected and that the continents were moving, but he could not explain how they were moving. And that was such an important piece that, that most scientists at the time just laughed him off. Now we have plate tectonics, which we'll learn about in 2.3, that give us that mechanism for how those continents are able to move. So there you go. Try to make sure that you have that gist on your sheet for 2.2. I'll see you for 2.3.